SN1, substitution nucleophilic unimolecular, first order essentially. Here's the basic setup of the reaction. A leaving group takes a pair of electrons with it, creating a carbocation, and whatever the leaving group happens to be. It could be a water, it could be a halide, it could be a whole host of things. A nucleophile then attacks this carbocation, and since this ring is planar, it can go above it or below it, and the result will be a racemic mixture, and the stereochemistry can be retained or it can be inverted. A couple of things to think about with these reactions are very simple normally, is to focus on the leaving group. In order for this reaction to be successful, it needs a good leaving group. Otherwise, it will never take place. This is why it's a first order reaction. It's dependent on this thing's ability to leave, because this second step is very fast. And the next thing to take in consideration is the stability of the carbocation, because the reactivity of SN1 reactions will favor those with stable carbocations, things that, like say, a more substituted carbon, such as this will be better suited than this, because this can get electron stability from these other carbons while this one cannot. Also, another thing to be aware of is that shifts often occur in SN1 reactions in order to get the stable carbocation. An example might be something like this. And if this were to leave, this is a carbocation, then this hydrogen would shift over here. It's called a hydride shift. Also, there can be methyl shifts as well. If this were, instead of a hydrogen, this were a CH3, and this were a CH3, then this whole thing would go over here, and then the carbocation would form on the more substituted carbon.